in today's lesson, we're going to kind of do a virtual demonstration or investigation on what you would be doing in class, looking at the CBR and how you can graph movement. So generally speaking, we would be using a CBR to kind of track your movement, and you would be looking at how can we get an image like the ones we see here in graph 1, graph 2, 3, 4, and so on. How would we get those different graphs? So I'm going to show you a kind of more virtual demonstration of this, where we're going to be looking at kind of a tortoise and a hare, or a tortoise and a dog race, and we're going to be graphing different representations, and we'll see visually what it looks like. You would be doing something else in class, but the idea is going to be the same generally. So what we're going to do, based on the first one, we have our tortoise here. Now, we would normally have to draw in the other graph for a dog or for another individual, but in this case, this graph right here matches the first one on our page that we can see here. So we're going to look just at this one. So we're going to go next, and we're going to watch what happens on our graph and the tortoise. So when we have a straight line that's increasing like this, let's see what that means in terms of distance over time. So as we see it, we can see that the tortoise goes along the path. He's getting further and further away, or closer and closer to the finish line, and eventually he crosses, and that's it. So when you see a straight vertical line like this, it's basically saying that an individual or something is just increasing or getting further and further away, and they're moving at a constant pace. Now, let's draw in what we saw in the previous one, or in our next example, which is this one here. So let's draw what this graph would look like on our little graph here. So our line is starting higher up, it's increasing, and it decreases. So it looks something like that. So in our next race, we're going to be focusing on a dog. So you're going to see a dog moving. The tortoise is still going to do that same movement from before, but let's see how the dog's movement changes now following this blue line. So the dog was out here. He's getting far ahead. Oh, and now he starts reversing. He starts moving backwards, or getting closer and closer to the start. So I'll play it again, and again, the dog will pop up. So watch over here around this first bend. So there the dog appears. So the dog starts further ahead, gets to a point, and then starts moving in reverse, or getting closer and closer to our starting line. So that's what happens when the line moves up. That means basically we're starting further away from the beginning. And when it starts to decrease, or our line starts to decrease, it's not that he's getting slower, it's that he's moving backwards or moving closer to the start. So the distance is decreasing. Let's see what we can find with our next one, graph number 3. So the line starts at the top, then decreases, is flat, and then decreases some more. So let's see if we can draw that in here. So it starts at the top, goes down, is then flat, and then decreases some more. So something along the lines of that. That does look very similar to what we see in graph 3 there. So let's see what this is going to look like. And again, we can see our two graphs. So the dog started back here. Oh, what happened? Okay, he's moved backwards. Now he's stopped. Oh, and now he's moving back, but slower. And we still see the tortoise moving. So let's repeat that again. Again, look around the bridge. You'll see the dogs there, moving back fairly fast. Oh, okay, now we've hit a pause. He's stopping. And now he's moving back slower. So we do see a couple of new things here. The steepness of the line talks about how fast our dog is going. He's moving faster in the first part, and it changes after. This flat line or straight line here causes our dog to stop moving. So we're adding in some new things now. So the steepness of the line changes the speed. A flat line changes the, or causes our dog to stop entirely. Let's look at graph number 4. So this one's going to be a little interesting. So it's going to be kind of like we're drawing a W here. Hopefully now you kind of can predict, what do you think the movement's going to be? Where is the dog going to start compared to the tortoise? How is his movement going to look? Is he going to be moving closer to the finish line or closer to the start? Is he going to be moving fast or moving slow? So we can see our graph here. Let's see what's going to happen. Oop, sorry. There we go. Now we can see it. So let's see what is going to happen with our dog. Oops, so our dog is moving back really fast. Oh, now he's moving forward. Oh, now he's moving back. Oh, now he's moving forward again, a little bit slower now till the end. So again, we can see that movement, right? Decreasing line means you're moving closer to the start. Increasing or line going up means you're moving further away. And the steepness tells about the speed, because we can see the speed change in the different portions. Let's watch that one again. So again, hopefully you're seeing that change in direction or change in movement, as well as the change in speed for our dog. Let's see if we can get graph 5 and graph 6 on here. So this one's going to be a little tricky. We're not using straight lines now, because as we can see that our graph is curving upwards. So it's starting a little bit higher, starting off slow, and then starts to increase. So let's see, kind of roughly drew it here. Let's see how this one is going to look. Oh, so the dog's kind of moving slow, moving slower, moving slower, moving slower, moving slower. Oh, now he's speeding up. Speeding up, getting faster and faster and faster. Oh, and he got really fast at the end. So a little bit of it was partly the shakiness of my drawing, but hopefully you saw that once it was kind of straight, the dog was moving fairly slow, and then he started to pick up speed and get faster and faster. So this is different. When we have a curved line, our speed is increasing. So our speed is changing. We're not moving at one speed like we were in the other ones. So here we're moving a little bit, or we were accelerating, you could say, in terms of speed. Let's try to look at graph 6 and see, what do we think this one would look like? What would our movement look like here? It's kind of a flipped version of what we just saw. And again, because we're dealing with, we have to actually draw our line in now. Hopefully my drawing will help. So there I have my drawing, again, roughly similar to what we're looking at on that page. Let's see what our dog's movement is going to look like. Oh, we went really fast, and then he's slowing right down. So he jumped out and was moving really, really fast. Now he's slowing down, and the turtle just passes him. So this was kind of the opposite of the one we just saw. Here they're not really accelerating because they start off at a fast pace or fast speed, and we'll see it, watch it again. So he's moving really, really fast, and then we slows down almost to a crawl, and the turtle ends up catching up to him. So in this one, when the line's curved like this, we're not accelerating, we're decelerating, because you can see that steepness is really steep and then it gets more and more shallow. So that's what's happening there. Let's see if we can replicate number 7, and we'll take a guess at graph 8. So again, hopefully we see now, we can kind of understand what's going to happen here, because now we're kind of combining the movements, the direction, sorry, the curved lines, as well as the directions and the curved lines rather than straight lines. So this one's going to be a little bit difficult because, again, my drawings skills on the computer aren't the greatest. But here we have the rough general idea. So let's see what our dog's movement is going to look like. Oh, so he started off, now he's moving backwards slowly. Now he's moving forwards quickly. And now he's moving backwards slowly and then quick. Slows down. Now moving faster. So he's just kind of going in that kind of slow reverse and slow acceleration. Slow, like the deceleration, acceleration, moving forwards and backwards, kind of combining that. So let's take a look again. So reversing, accelerating forwards, then slows down, reversing fast, and then slows, decelerates, accelerates forward, decelerates, accelerates backwards. So we can see that kind of constant back and forth movement. But again, with the acceleration and deceleration as we get closer to those peaks and valleys. Let's try to guess what would happen with graph number 8. Now, graph number 8 is interesting because we have straight lines, but they're a little bit different. We haven't really seen anything like this with straight vertical lines. So what do we think is going to happen here with those vertical lines? And this one might have been difficult to try on your own, but let's see. We're going to replicate that graph in our little interactive, and let's see what happens. So here again, we can see I've changed it up a little bit, but we see that general flat line, vertical line, flat line, vertical line, and so on. Hopefully you remember from before, we do know what the flat line represents. So this line represents standing still. What's the vertical line going to represent? Let's take a look. There's our dog. Oh, he stopped. Oh, he's moved. He's now over here. Now he stopped, and now he's over here. He's back. Now, so he's jumping spots almost instantaneously. Oh, you can kind of see a small glimmer of him moving, but I think the idea is that he's almost teleporting. So let's see. So here we know flat, stopped, instantly moves. And instantly moves. Almost, we can't even see any movement from one spot to the next. You see a little bit of a glimmer, but that could just be more of my drawing and how it's not a quite vertical line. It's slightly slanted. So what's happening here is that this vertical line basically means that at this point, or at this time, our dog is at every single one of these positions simultaneously for a split second, or like less than a second, almost like a microsecond, probably even smaller than that. And then he appears at this distance standing still. And then once it hits this time, he's at every single one of these points almost instantaneously, and then we see him appear back at this distance. So what we're seeing is him kind of instantly jumping from one point to the next, or almost existing at multiple spots all at the same time. So really, these vertical lines is going to be very difficult for you to replicate on your own because you can't instantaneously jump spots like our dog can. So let's take one more look at that one. You can see he stopped here, then you'll see him instantly jump over here. He stopped, then he'll instantly jump back. Then instantly jump back. And so he's kind of teleporting back and forth in split seconds. And again, that's going to be very difficult for you to kind of mimic on your own, but there are ways or tricks around it. So see if you can try to do those on your own. But again, the idea is that you're trying to see what these movements are going to look like. So let's just kind of do a quick summary. So if we were to sketch a graph of someone walking away from a motion sensor, the distance would, or the line would kind of look something like this. With our line increasing, the distance is getting farther away. If they're walking towards the motion sensor, that means they're starting away from it, and the line is decreasing because they're getting closer. For C, if they're standing still 1 meter away from the motion detector, we would have a flat line. Because a flat line means we're standing still. Our distance isn't changing. If they were walking fast, fast would be a very steep line. Whereas if they were walking slow, it would be more shallow. If they were walking at a constant speed, walking would be, I'd say, because it's relatively slow, be something like this. But the key thing is constant speed, which we're going to indicate more clearly with as a straight line. And for G, if they're starting slow and then speeding up, so we have seen that. So that's kind of that acceleration that we talked about. Anytime we have acceleration or deceleration, we have a curved line. So the curved line curving up means accelerating. If it was curving down, it would be decelerating. So when we look, so let's kind of recall. So if you created these three graphs, or you kind of look back at the images or the kind of investigation that we just did, what's the same about these ones? And the same, we're moving away from the start, or from the motion detector, whatever you want to call it. So that's kind of the key thing. You're moving away from the start. The difference is, we'll say graph 1 has a constant speed. Graph 5 has increasing speed, which we'll call acceleration. And graph 6 has a decreasing speed. So this is where we're slowing down. So this is our deceleration. I don't even know how to spell acceleration. So we have our deceleration there. So acceleration or deceleration. So the difference is the speeds in our graphs. They're all moving away from the start, and the other ones, the differences are the speed at which we're moving them. So again, that's kind of a summary of what you would have looked at using your own motion, and this is looking at kind of, again, what we did today was kind of more the investigative part. So again, as long as you understand how your movement can translate to a line on a graph, or how lines on a graph can represent different types of movements in terms of like a CBR or the investigation that we just kind of looked at. Those are the key concepts. And we'll look at putting it more into actual like mathematical values in the next lesson.